Okay, so on Wednesday of last week, we started discussing the first material for this course, which essentially covered these 4 points: product design, process design, schedule design, and facilities design. And the goal, as I mentioned, was to find out how these 3 first topics relate to the facilities design process. So going back to the learning objectives for this lecture, which was the lecture that we started already, the first objective was to learn the product, process, and schedule design functions as they relate to facilities planning. We covered the first 2 already. We are about to finish schedule, and we're going to cover one more thing. And the second objective is understand the interactions between facilities planning and the product, process, and schedule design. Okay, so the figure basically shows you that all these things, these first 3 things, are related to the facilities design process. So this was the last thing that we discussed on Wednesday. Here we were trying to find out what was the required input for this process in order for you to be able to have an output, a desired output for this process, which was 97,000 units. And we saw how the defects can affect that input. So here we have 3 different operations, and each one of the operations will have some defects after processing. So we are taking that into account so we can account for the number of units that we need to start a process with. And we compute this using 2 different methods. The first one was by looking at each operation individually, and the second one was by looking at the 3 operations at the same time. So in purple, we have the expression for when you consider all the operations at the same time, and in red we have each operation separately. Any questions? So the next thing was to see, right now we are just not counting those units that are defects, but most of the time you want to do some rework on those units so you can get them back to production. So on the next example, I'm going to derive an expression that will account for those units that are taken to rework, and that will be part of your output. Okay? So this is the process that I'm referring to. Here we have 2 operations, 2 series operations. This one and this one, but we have an additional operation, which is the rework, which is operation number 2. So those units that are defects are coming with defects from the first operation. We're going to perform some rework, which is this operation, and then we're going to take them back to the process. Okay, so from those units that are considered defects from the first process, we're going to get some of them. That's going to be our output, but we're still going to have some of them that we are not going to be able to fix, which are the ones that are going through this arrow here. Is that clear? So 2 operations, an extra operation for rework of the first station. From that operation, we're going to get some new, well, not new, but some additional units that were considered defects initially, and those are going to be taken to the 3rd process. So in order to find out what's I1, That's our goal. The calculation of I1 based on the required output which is going to be O3. So we know that the output of the first operation is going to be 1 minus the percentage of defects times the input that you're receiving from your system. Okay, so that's our output from that first operation. And we know that we're going to have some of them that are going through to be defects or have defects. So that's going to be the input for the second operation, which is the rework operation. So that input for this operation will be D1 times I1. Those are the defective units from the first process. Then the output from this operation, that's going to be O2, is 1 minus the number of defects from that rework operation times the input for that rework operation. Okay, so again, we are trying to derive an expression that will let us know what's the initial input if you want to have a desired output from your last station. And now we are considering the rework. So now we have an expression for the first station, we have an expression for the second station, so we can use that information to get the input for the third station, which is this one. And we know that's going to be equal to O1 plus O2, which is the output of the first station and the output of the rework station. Both of them combined will give you the input of the third station. This looks like, if you're familiar with circuits, this is kind of the analysis that you do. You're trying to find the current and so on. So we can use this information to create a new expression. So that's going to be equal to 1 minus D1 times I1 plus 1 minus D2 times I2. In solving this thing, we know that I2 is equal to D1 times 1 I1, so we can get 1 minus D1 times I1 plus 1 minus D2 times D1 times I1. So we are substituting this part into this equation. And then we can solve for I1. So I1, that's going to be equal to I1 times 1 minus D1 plus D1 times 1 minus D2. Thus, I1 is going to be equal to I3 divided by this 1 minus D1 plus D1 times 1 minus D2 and since we know that I3 equals O3 divided by 1 minus D3, I1 is going to be equal to O3 divided by 1 minus D3 times 1 minus D1 times D1 times 1 minus D2. So now we have an expression that will let us know if you know the desired output, which is O3, and you know the number of defectives that you're going to have per station, you can compute the initial input. Yes, sir.
So last part of the equation, after the 1 minus D1 plus
I'm sorry, yes. It should be D1 times 1 minus D2. So if you know the information in terms of the percentage of defects for each station, and you know the desired output, which in this case is O3, then you can compute the initial input for your stations. And that was the goal. Okay? So you can use this expression if you have some rework in your systems. As you might think, what happens if you have more stations, then you're going to have to go through the process of deriving an expression for accommodating the number of stations that you have. But it should be easy to do if you follow these same steps. Any questions? Okay, so that example concludes the schedule part of this lecture. Now we're going to transition to discuss in general what are the tools that you can use to design a facility. So I'm going to discuss some of the tools. These are tools that are used in systems engineering for different type of problems, and they can be also applied to facilities design. So once the product, process, and schedule design decisions have been made, the facilities planner needs to organize the information and generate and evaluate a layout, the material handling equipment or needs, the storage needs, and the unit load design alternatives. And we're going to go over each one of them throughout the semester. But for now, there are 7 management and planning tools. So the 7 management and planning tools have been used lately as a methodology for improving the planning and implementation efforts for facilities design. So I'm going to discuss them briefly today, and we're going to refer back to them as we need during the semester. So the first one is called the affinity diagram, and it's used to gather verbal data such as ideas and issues and organize them into groups. So for instance, if we have an issue in terms of reducing the lead time, meaning that anyone knows what the lead time is? So if you're trying to build a engine and you have multiple components coming to assemble this engine, some of them might arrive in 2 days, some of them might arrive in a week, some of them might arrive in a month. So that time frame is the lead time for each one of the components. The time that you're going to wait to get that assembly or component into that final assembly. So here in this example, you are trying to find out what are the issues reducing the manufacturing lead time. So we can see that from different point of views. In here we have 5 columns. One of them is the facilities design, which are the issues that relate to this course. So for instance, one issue can be how to form the product families, and we're going to talk about that on our next lecture, on lecture number 2. Also, assign families to cell. If you are not familiar, cell is a concept used in cell manufacturing, in which you have, if you have products that are similar, you can produce them using the same production line. But this production is not formed in a line, it's formed in the form of a cell. Most of the time it's a circle way. So you can use the same equipment, same materials to produce different type of products that are similar. Assign raw MTLs to their point of use and keep receiving and shipping close to production. In the same way, you can discuss and raise some questions about what are the issues related to equipment, quality, setup time, and scheduling, and these two will help you organize those thoughts and issues. So that's the good thing about this diagram. Then this is called the interrelationship diagram. This is also called a block diagram. Basically what you're trying to find out is how things are related to each other using arrows. So it's used to map the logical links among related items, trying to identify which items impact the others the most. A tree diagram is very similar to the previous one, but this one provides more detail. So you're going to have more branches, and you're going to start linking those branches with each one of the important issues for this design. This one, I find it very useful, the matrix diagram. Organize information such as characteristics, function, and tags into set of items to be compared. This one is good to organize qualitative data. You can use any type of mapping or legend. So here we have an L to describe the team leader, C the team coordinator, and P the team participants. And you can basically list the issues related to your problem, and then you can decide which one of the team members is going to be taking the lead as part of the problems, and so on. So this is a very useful diagram. It's called the matrix diagram. The next one, this is called contingency diagram, and this one maps conceivable events and contingencies that might occur during implementation. So if you come up with a model or design and you want to implement that one, this basically allows you to predict what things can go wrong. So it's particularly useful when the project being planned consists of unfamiliar tasks. So, for example, if you think you can be late, what are the reasons that can that will make you be late for this class, for instance? Some of the things can be you're out of gas, your clothes got dirty, or you are not able to listen to your alarm. So that's the type of thing that can make you be late this class. And that's the type of thing that you can use in this diagram. The activity network diagram, pretty sure that you have seen this one before in your project management class, in your production course. So here is used to develop a work schedule for the facilities design effort. So if you have multiple steps in order to complete the facilities design, you can always use this diagram to try to schedule those activities. And the diagram is synonymous to the critical path method discussed in project management. The next one is called the prioritization matrix. So we can list some alternatives that are important to consider for the problem. So for instance, layout characteristic, material handling requirements, unit load implied, storage, warehousing, and so on. And then we can create a matrix. Well, first we provide some weights in terms of the relationship between the areas that are important for this design. And by providing that weights, say one is equally important, significantly more important, we can come up with the best, or not the best, but the most important issues related to your future design. So as you will expect, you're gonna have a column and a row for each one of these items, and for those items that are the same, you're gonna have a 1. So this is diagonal 1. And then when you start comparing them, for instance A and B, total distance travel and manufacturing flow visibility, how those two things relate in terms of importance. So we are saying that that's very important, significantly more important than other issues, that relationship. So once you get that information or those relationships between those items, then you can start computing the totals for each one of the rows and each one of the columns, and that should give you some guidance in terms of what are the things that are more important for your design. Any questions? So finally, this is just to give you an idea of how you can apply these tools in real life. So if you want to have a sequence on how to apply these tools, you can follow this flow chart. So you can start with affinity diagrams and interrelationship diagrams, and then go into more detail with the 3 diagrams. Then find out what are the relationships with the prioritization matrix and the matrix diagram, and find out then about the information is known, unknown, and you can finalize with the activity network diagram, which is what we discuss in project management in terms of scheduling the tasks that you need to be completed to get your design. So again, this first lecture is the idea was to give you a summary or a general description of this process, product and schedule design, and how all these 3 things relate to facilities design. Now we're going to get into more details with the following lectures. So that basically concludes this first lectures. Do you have any questions? You're going to have your first homework assigned today, and the homework is going to be covering the material part of this lecture. Okay, from this lecture, the homework is going to be from this lecture, and that homework is going to be due in a week. So you will find that homework on tracks, and you're going to have to submit it at the beginning of the lecture on Wednesday, next Wednesday. Any questions? Yes, sir.
Will you post the completed slides?
No, I will post the videos, but I don't post the slides with the information. Okay. Any other questions? Okay. So now let's transition to the next topic. Which is called flow activity relationships. And the material, or you can read part of your textbook, chapter number 3. The material that we're going to be discussing in this lecture, part of it is coming from that chapter: flow systems, activity relationships, and space requirements. And I always shows you this just to keep you informed about what are the things that you need to learn in this class. So I'm not gonna go over that, but just keep those 4 points. So by the end of the semester, you should be able to master those 4 items. But the agenda for this lecture is I'm gonna give you an introduction about these topics, and then we're gonna cover flow system, material flow system, departmental planning, layout types based on material flow systems. And then I have divided this lecture into the part number 2 of this lecture are going to be a separate group of slides. It's going to cover the activity relationships, and we're going to discuss some of the diagrams that are important to identify. Let's say you're trying to define or design this new plan. I was watching a video for Tesla yesterday. These guys, I don't know if you're familiar with Tesla. These are the electric vehicles. No hybrid, no combustion, it's just electric. And they're doing very well. So they bought this facility in California, which used to be part of Toyota. And these are a new product. There's no manufacturing process, there's no anything that has been decided before for this type of product. So they need to come up with new process, new layout in order to be able to produce these cars with a production schedule that I think they already sell like 1,000 cars. So they need to fulfill this schedule in 2 months. So they were talking about these problems that they had in how to design the manufacturing plan, what are the things that they need to consider, because this is something new that they haven't done before. So that includes the departmental planning, meaning that which departments are going to be part of this new facility, how are they going to be related. So if you need to take this vehicle throughout this line, what are the things that you need close to the vehicle so you can assemble all the components that are important. So you're going to be discussing part of it here in this lecture. Layout types and material flow systems and so on. So let's get started. Just wanted to give you that example because there's a lot of new things, new products coming to the market in the last few years, and most of those things are happening in the California area. So you can find a lot of information and videos about those things in the internet. So the learning objectives: understand the interactions between flow system, flow activity relationships, and space requirements as they relate to facilities planning. So we're going to start by discussing flow systems. This is the movement of goods. Let's go back. Goods, materials, energy, information, and or people in your facility or in your department. A flow process may be described in terms of the subject of flow. So maybe it's a turbine for an airplane. It has to be moved throughout the facility in order to be completed. or maybe we are talking about smaller items such as cell phones or anything else. The resources that bring about flow, and the communications that coordinate the resources. So the subject is the item to be processed. The resources that bring about flow are the processing and transporting facilities required to accomplish the required flow. So you can have conveyors, you can have guided vehicles moving stuff around the facility. You can have machines that are stationary that you have to bring the product to it, and so on. And the communications that coordinate the resources include the procedures that facilitate the management of the flow process. So if you're familiar with the Toyota production system, there's certain things that they do, like the Kanban system, that allow you to know how many units are required. If you're starting in one of your stations, then you will know right away because of the system of cars that they have available, and so on. So those are part of the communications between resources. Flow systems for the discrete parts process can be categorized according to the stages of the supply, manufacture, and distribution cycle. And the three categories are the materials management system, the material flow system, and the physical distribution system. Okay, and this diagram here, it's showing you how are they related. So the material management system will have some communication with the material flow system, and the material flow system will have some communication with the physical distribution system. The physical distribution system will have communication with the customer, and the customer is going to communicate back with the physical distribution system. Okay, so in general, what we're trying to represent here is that we're going to have a vendor, which is the owner, is going to be taking care of this or communicating with the material management system to see what are the needs from or the company in terms of sales, in terms of what's the future demand, how we should prepare about the future demand, and so on. And then from that perspective, we're going to go in more detail how we should move the material within the facility, that material that is needed to accomplish the future demand. And then this guy right here is going to be dealing with the real customer, which is going to be making the orders, and is going to be seeing how much material we have available to satisfy those requirements from the customer. So we're going to talk about those in detail in a second. So the materials management, material flow, and physical distribution system might be combined into one overall flow system. And this flow process is referred as the logistics system. So all these three things is what we call the logistics system. And if you go to any major company, let's say HEB, Walmart, UPS, FedEx, you will see that each one of these companies have a logistics department, which is basically in charge of planning all these things. So if you are interested in this area, there's a lot of things that you can do in these large companies. Also, I don't know if you're familiar with the term supply chain. If you took Dr. Jean's class, the supply chain is what involve these two areas. Okay, so let's go and discuss what are the things that are happening in these three major areas. Starting with the material management system. So I'm gonna use MMS just to shorten the material management system. Is the flow of materials into a manufacturing facility. The subjects of the material management systems are the materials, parts, and supplies. Purchased by a firm and required for the production of its products. Okay, so again, this is based on forecast. The resources of this materials management system include the production control and purchasing functions, the vendors, the transportation and material handling equipment required to move the materials, parts, and supply, the receiving, storage, and accounting functions. And the communications within the material management systems include production forecast, inventory records, stock requisition, among others. And I'm going to show you some of the functions for the material management system on the next slide. So remember, this is at the top level. We're trying to plan at the top level. So we're going to have some forecasts about the production. And we're going to send that forecast. We're expecting to have I don't know, these many orders coming from this client in 2 weeks. We are expecting to have these many orders coming from HEB in a month. We're expecting to have these many orders coming in 2 weeks from Walmart. So we need to decide how to run our materials management system. So we're going to put these stock requisitions into the purchasing department, and those are the ones who are going to be in charge of making the purchase orders to the vendors. And then we're going to have to bring those items into the facility. So the vendors is going to be in charge of bringing those items. Transportation, you're going to receive those items, and the accounting department is going to be making the payment to the vendors. And we're going to take that those items, we're going to put it into the storage. Those are the materials that we're going to need to start our production. So those are the raw materials. And that's part of the materials management system. Now we transition to the next one, which is the material flow system. And the material flow system It's the flows of materials, parts, and supplies within the facility. So now we are inside the facility. We got the raw materials from the vendors. Now we are inside of the facility. So the subjects are, again, the materials, the parts, and supplies. Used in manufacturing products and components within its facility. So the resources of the material flow system include the production, control, and quality control departments, the manufacturing, assembly, and storage departments, material handling equipment required to move the materials, the supplies and parts, and the warehouse. Those are the resources that are going to be part of this material flow system. And we're going to use different other methods of communication for this material flow system, including the schedules, work orders, Kanbans, barcodes, route sheets, assembly charts. We talk about those in our first lectures, and also the records from the warehouse. So all that information is the communication for this system. So that's the material flow system. We went from buying the raw material to the movement of materials within the department. Yes. Kanban is what I referred to the Toyota production system. This is a group of, this is a system that's implemented in production facilities that once you move let's say a group of parts from one station to the other, there's a car that is transferred from that station to the other to let you know that you have this certain amount of materials, and to let them, the warehouse for instance, to know that they are losing these many units so they can plan for the next stage. That's a good question. Any other questions? Good. So here is the material flow system. Here we have the production schedule, and we're going to go to the production control, and that's going to tell us what are the items that we're going to get from the store. We're going to use some material handling equipment to move those materials from the store, and we're going to take them to the manufacturing departments. And those manufacturing departments are going to send them to the appropriate assembly stations or workstations, so you can start assembly in the assembly department. And once you have the items completed, then you move them to the warehouse for when the customer requests them. So again, we are within the department, we are moving the raw materials to production, and we are getting some finished goods. And now we move to the third one, which is the physical distribution system. And the physical distribution system is the flow of products from the manufacturing facility. So now you have your finished goods, you have your finished product, now you want to move that to the customers. In this, the physical distribution system, the materials or the subject of flow are the finished goods. Produced by a firm. And the resources for the physical distribution system includes the customer. You're going to be dealing with the customer now. You're going to be selling them the product. The sales, accounting departments and warehouses, the material handling and transportation, you're going to have to move that product to your customer destination, and the distributors of the finished product. And again, the sales communication includes sale orders, packing lists, shipping reports, shipping release, Kanbans, and bill of landing, which is basically once the product is arriving to the customer facility, you receive this bill of landing. In terms of the flow of information, physical distribution system, you're going to have a customer who's going to place a sale order. That's going to go to the sales department. Sales department is going to send that information to the warehouse, and the warehouse is going to be in charge of setting up the steps to make that product available to your client. So we're going to send a shipping report to the accounting department. We're going to prepare an invoice to the customer. The customer will pay, and then we can transport the items to your customer using your distributors, or if you are having a logistics system that allows you to deliver the customer's items straight from your facility, that's also a possibility. But if you have some subcontracts, you have some distributors that are in charge of transporting your goods, that's also part of the system. And once the transportation is completed, you have some bill of lading making the customer saying that they received the goods that were requested. Okay, so as you can see, these three diagrams shows you from the top level of the company to the low level, meaning that you are done with the production, how the materials flow systems work. So we have three areas. We go back to that. And these all how they relate to the vendor and to the customer. Now we're going to go in more detail about this material flow system, which is the middle part of this diagram. So that's what we're going to do now. Because we will focus on material flow systems with emphasis on flow patterns and structures as viewed from the perspective of flow. From three perspectives within workstations, within departments, and between departments. Okay, so we're going to focus on material flow systems. This is what's happening inside the facility. And we're going to see that from three perspectives: within the workstations, within the departments, and between the departments. So the first one is basically designing the workstation for your employees. So if you are going to have a person assembling a particular component for a cell phone, you might see some of the buckets with parts, and they're going to be grabbing those parts to put the component together. So for those type of flow, we have motion studies and ergonomic considerations. So here I'm showing you a graph or a picture of some of the things that are considered while you are designing a workstation. If this person needs to reach to grab some of the components, those need to be available to the employee within a certain distance in order to satisfy the requirements, the ergonomic considerations. So that's what's showing up here. In this course, we're not going to go in detail on how to design a workstation. That's not part of this class. If you are in the industrial engineering program, we have a course for that. This is called Methods, Engineering, and Ergonomics, which is basically goes in details on how to design a workstation and what are the things that are considered in terms of ergonomics. But that's not going to be part of this course. You're going to focus more on the flow within departments, and the discussion will focus on flow within product, process, and product family departments. So there are three types of flows that could happen within the department, and those are the main three: product, process, and product family departments. And on the first one, flow within the product department, the flow of work follows the product flow. Which basically you take the product from one station to the other. Once you perform some activities, you take the product to the next station, and so on. So there are several strategies that you can use to design such type of flow within the department. Here I have 5 of them. The first one is called the end-to-end, in which you move the product from this table to the other, this table to the other, and so on. So the flow follows that line. B, back-to-back, so you're taking the product from this table to this table, and then you release the product. Z is you're staying in the middle of the stations, and you move this way. You finish, you move this way, and then deliver the product. D is the circular. This is what we usually see in the cell manufacturing. We have multiple stations in this circular fashion, and you're moving the product from one station to the other, and then deliver. And the last one is an up angle. Maybe you have a machine that is big, that is taking you some space in this area, so you might need to design around that machine. That's something else that can happen. But those are the more general type of flow or designs happening in a product department. Any questions? Now, in terms of flow within a process department, we're going to have similar or identical machines grouped in the same department. So when I was working for Johnson & Johnson, we used to have, let's say, since we had a RC man for developing the Tylenol and so on, we might have same, let's say, three lines of the same process on the same department, so we can get more production from the area. And that's the type of thing that we have in the process department. So you're going to have similar or identical machines grouped on the same department. Minimal amount of flow shall occur between workstations. Within departments. Flow patterns are dictated by the orientation of the workstations to the aisles. And that's very important. When you go to a manufacturing facility, you'll see that the aisles are marked, it's yellow colors or red colors. So nothing should be placed on those aisles. Those are very important. Those are for transportation purposes, and so they should be kept empty or free. The delimitation of the preferred workstation aisle arrangement pattern is depending on the interactions among workstation areas, the available space, and the size of the materials to be handled. So the most common type of arrangement that you're going to find is this one or this one, which you're going to have only one aisle to move from one station to the other, and this one you have two, This one is less common. You might see that one when you have a limitation in terms of the space, so you need to accommodate, let's say, big machines in a limited area. You might put them in a diagonal type of way, but that limits your flexibility, because if you have a limitation of space, you need to plan for having at least 2 aisles for that type of design, one for moving one direction and one moving for the other direction, and that limits your flexibility in terms of production. But in general terms, you have these 3 options, making the most use the first one and the second one, the parallel and the perpendicular. Any questions? Then we have the flow between departments, and this criterion often used to evaluate the overall flow within a facility. The location of the pickup and delivery stations for each department is important. So if you're in charge of such type of decision, just make sure that you are planning the flow by taking into account where are the goods coming, or the materials, the raw materials coming, and where you're going to have your area for sending those goods that are produced. Some of the companies might have those 2 things happening in the same location, so you have the entrance and the exit in the same area. So you can design for having different type of flow patterns. That's also happening here. So here you have different flow patterns for entries and exits on the same location. Then you might have other type of facilities like this one, in which you're going to have an entrance in one location and then the exit on the other extreme. So that limits also the type of flow that you will follow. So this gives you some type of guidance on what the type of flow that you can use when you have those equations. Same thing here. We have one stream the exit, the entrance, and one extreme the exit, and so on. So when designing the flow between departments, it's very important to find out where your entry and exit points are, because that basically tells you the limitations that you will have in terms of the flow that you can choose for your department. And we're going to discuss more about this on our next lecture using the activity flow diagrams. So effective flow planning is a hierarchical planning process. So you're gonna have to start with some elemental planning steps, and then go to more complicated ones. So starting with the workstations, you move to within departments, and then you move to flow between departments. The following principles have been observed to frequently result in effective flow. If you try to maximize the maximization of directed flow paths, is one thing. Another thing is the minimization of total flow and finally the minimization of the cost of flow. Okay, so if you're designing to have an effective flow within your department or between departments or within your workstations, these are the three things that you can use as objective functions. Try to maximize the flow of the directed path, the minimization of the total flow, and the minimization of the cost of the flow within and between departments. And again, we're going to have some models that will allow you to focus on these three targets, and that's going to be covered later in this class. But now let's talk about departmental planning. So planning departments can involve production, support, administrative, and service areas. Okay, so we discussed the importance of the way your the flow goes within your department, but now we want to know what are the things that are important when designing the actual department. So we're gonna have to plan for the production areas, support areas, administrative areas, and the service areas, including restrooms and dining areas and so on. Everything that's required for your employees must be part of the department design. Production planning departments are collections of workstations to be grouped together during the facilities layout process. And depending on the product volume variety, product planning departments can be classified. There's four actually type of classifications. First one is called product. Fixed materials, location. Then we have product family or group technology or process planning departments. So the first thing that you have to understand when you're designing this new department is what type of item or what type of product are you producing in your facility. And we can decide, we need to fit your product in one of these three classifications. If it is a product, fixed materials, if it's a product family, or if it is a process planning department. And the best way to do that is by following this graph. So we're going to look at the volume of your product, and we're going to look at the variety of your product. So if you have a low volume in terms of production for that item, and you don't have as many variations of your product, then you can classify your product as a fixed location layout with fixed materials locations planning department. So you can have an area in which you're going to have your product and everything is going to be done to the product in that same location. If you have a high volume with a low variety, you can use a product planning department or product layout. And same thing here, if you have a high variety and a low volume, then you can use a process layout with a process planning department. And if it is medium, then this is what we call the fourth one. We're going to have a product family planning department with a group technology layout. And we're going to discuss each one of them in detail now. But that's just to give you an idea how you can classify your product and what type of layout you're going to have based on your product. Here's a nice table. This is coming from your textbook. This is a procedural guide for combining workstations in planning department. So if you have a product that is standardized and has large stable demand, then you can look at the second column and say the type of planning department should be a product line, product department. And the method of combining the workstations in one department is by combining all the workstations required to produce a product. As I was saying, you're going to keep everything close to the product. But if you have a product that is physically large, hard to move, and have low sporadic demand, let's say an airplane, you can have a fixed material location product department, and you're going to combine all the workstations required to produce the product within the area required for tagging the product. And so on. So you can read through this. This is also a good guideline to help you decide what type of department you need to plan. Let's now discuss in detail each one of them. So we can start with the product family department. The product family department, this aggregate medium volume variety parts into families based on similar manufacturing operations or design attributes. So here I'm showing an example of some boards that may change a little bit, but as you can see, they are very similar. That can be called a product family. The machines required to manufacture the part family are grouped together to form a cell. Thus, the label cellular manufacturing. And if you don't remember, this type of layout that we show, that the flow will go like this. So you're going to move around the cell. We can decide, there's several methodologies to be able to decide how many cells do you need within a department. Here in this class we're going to discuss one, which is called the direct clustering algorithm, or DCA. And this methodology clearly illustrates the important features of the cell clustering problem. This algorithm is based on a machine part matrix in which 1 indicates that the part requires processing by the identical machine, the indicated machine, sorry, and a blank indicates the machine is not used for the particular part. And I'm going to stop here, and we're going to start from this next time. We're going to discuss the algorithm. I'm going to show you an example of how to cluster cells within a department using these algorithms. Any questions? So again, I'm going to post videos from the past lecture and for this lecture, in case you have missed one of the or any part of the notes. And let me know if you have questions. Homework is going to be posted today, as I mentioned earlier. So make sure that you look at the track side